Okay. Hello everyone. I see there is some people already. That's great. Uh, so today, so it is the fourth stream. Basically, I meant only to stream the week because yes, we can have some other stuff to do. But yeah, so today's subject, well, it's a bit different because we already saw a lot of stuff. So on day zero, day zero we saw the features and well how to use the library which are up there. Then on day one we saw the biomes. I type dairy. Nope. On day two we saw quickly the noise and mainly the Perlen and simplex, even if we didn't go in depth. And what the fuck is it correcting to dairy? Okay. And day 3 today, so it will be about well, recursion, and in particular to Mineshaft, Fortress, and Stronghold. As you may know, those are generated recursively in Minecraft. So, today is recursion, and I think for today's subject we will make it in three parts. So first part will be understanding what actually I meant by recursion. What is recursion? Because yeah, we need to start somewhere. Then we will see how it is constructed in Minecraft. Maybe first we will see how it is done in Minecraft. So we'll see visually how it is actually done. Then we will see how it is constructed because actually, yeah, it makes more sense like that. And of course, I think in this video we'll see also about some more stuff. So I think because we will be playing with Minecraft code, I will show you how to actually, well, play with MCP because, yeah, maybe we'll see also about yarn, depending. Because those are quite important to know actually how to play with. Yeah, I think we'll tackle some other subject if we can. But basically, yeah, today is understanding what is recursion and how actually it's used. So yeah, for those who are quite advanced, we will not see something like that. We will not see DFU and the new stuff. We will see only the old stuff because yeah, the new stuff are quite complex and I don't think they fit in a stream because you need actually a video to understand them. But yeah. So, understanding recursion. I think maybe a lot of you, I don't know exactly if everyone knows recursion, but let's Google it because maybe it gives something interesting. Let's Google it because it's even funny. So if we Google recursion, first result is recursion. And that should give you already a hint what is really recursion, because it will give you always that. So recursion is repeating an action an indefinite amount of time till you hit a base case. And basically, the base case is like so. So you have a base case, you check first, and at that point you exit the loop, else you call the function, or you go to the beginning, and you update inside your parameter if you want, but you are not forced to update the parameter. It could be a side effect, could be a different stuff. And how we see usually recursion is like so, is something imbricated in another thing, imbricated in another thing, and so on. So yeah, it's recursion. I think a lot of people can see this, the property it gives, like if you go in some specific type of construction, so in the fractal for example, you can see actually the recursion playing very nicely. So those are the Sierpinski triangle, and as you can see it's a recursive structure because here you have 4 triangles, Then if you go in one triangle, you have actually 4 triangles, and so on. And each time is 4 triangle, till actually you can't see it because it's blurred. So yeah, so recursion is basically that, but let's play with Wikipedia, because why not? Recursion is a method of solving a problem where the solution depends on solution into smaller instances to the same problem. So it's basically building a tree, and at some point you are cutting down some branches because you have reached the condition you are wanting to meet. And now you are asking, why is it relevant compared to Minecraft? And the answer is quite, well, simple. It's basically because the construction of Mineshaft and Stronghold are recursive. And what I mean by recursive is that at the beginning, when you are choosing in the world, so you have your world, you are choosing a chunk. So because Stronghold, Mineshaft, and so on are just structure, in fact, you are choosing a chunk, which is the point you will start. So for Mineshaft, it will be the dot room, and then you are taking the 4 cardinal orientation, and you are trying to go in a direction. Then you will take either a left, right turn, or go along the same axis, and so on. And you will do something recursive. You will take path, and at some point you will cut, and you will have some kind of pattern. So for Mineshaft, it can look a lot like that. So it will be a lot of tunnels, because yeah, it's a Mineshaft. And that's actually done recursively, because making it without recursion, it's quite hard, because well, it's not hard. There is a way actually to do it non-recursively, but I mean, the principle behind is recursion. It's something that is same method that you are calling each time. So at the beginning you are choosing between the 4 directions, and for each direction you are actually calling the same method, which is either go straight, either take a left turn, either take a right turn, or again go straight. So yeah, you call it at most, well, the distance you want to cover. So Mineshaft can go more than 112 blocks away, and that's actually what is actually done. And that's great, because if you want actually to build a map, and you will want it to be well, procedurally generated, you don't want to have some model and just well, do it each time, because well, it makes no sense to play a game which is like that. So you want to have smaller components, which are called room usually, and each component you are just putting them together like a, well, a Lego set when you are putting bricks together, and you want to do a full ensemble at the end. And that's usually one of the, well, best way in a game to make something random, well, to make something look random, even though behind the scene it's not really random. It's just basically well, rolling a dice each time you are piling a new component, and each component you can make them how you like it. So that's actually the first part, which is understanding what is recursion and, well, how it can be used in Minecraft. So now let's play Minecraft. So let's just open an instance. Of course I will play 1.12 because it will be easier than to explain for later how actually, well, it works. But the principle didn't change between the version for Mineshaft, at least. For Fortress it's a bit different. And yeah. Oh, you will hear the sound. Maybe I will just get it a bit down. Okay. Shouldn't be, but okay. Let's play a game. Just open a world. I'm guessing you all know how to open a world and so on. It's not that much. Yeah, it takes time to open, but it will be fun. I promise. Well, fun. It depends if you like computer science. If you don't, then yeah, it will not. But Yeah, it's still great explanation to know how it works behind the scene, because if you know how it works behind the scene, then you can actually make a great model, and just afterwards it's way easier to do stuff. Because yeah, okay, maybe let's give me fact night vision 10,000 to. Okay. Where is my mineshaft? Mineshaft. Where is my mineshaft? It actually teleport to the right coordinate? Yeah. Why? There is no mineshaft. Actually disables the structure. Okay. Oh, structure are on. Yeah, I should have prepared maybe that part. That's weird. Maybe I'm playing some custom version I made. Locate shaft. Of course, everything will be recorded, so well, you're not forced to watch. I mean, if it's boring for you, well, go do something else, I guess. I wonder why there is no shaft here. Oh, there is one here. Okay. So effect. Yeah, and night vision 10,255. Okay, so this is a mineshaft. Let's find the center piece. So the dirt room. Where is it? Where is it? There's done. There is a spawner in the middle. Nice. No, that's not the dirt room. That's not. That's not fun. Why is it? Actually missed it. Should be. Except if it's destroyed, of course, because if it's destroyed, then yeah, you can find it. But darn it, should be at center relatively. That's not it. Maybe let's just teleport to random coordinate. Might increase our chance. Yeah. Okay. So, here, yeah, maybe this one it looks a lot better. So there should be, yeah, there is a dot room. Okay, so that's the center of the mineshaft. Let's put G. Yeah, okay. So it's in one chunk, of course, and then there is actually 4 under. So if you look, there is one here, which is chosen among well, this block. I think it's this block. It's 11 blocks. Then there is this one. This one is a side part. And then there is this one, and on this wall, it didn't show. Well, it didn't choose this wall. There's a chance that it doesn't show. Then if you go here, it chose to go straight. Then it took right turn, left turn, keep straight. Then it again look here, but because it was already connected to a path, it made this structure. Here it took right turn. Of course, there is some stuff that are generated among the mineshaft, but that's just a component. Which is important to notice is actually the pattern, which is to generate each time, well, either go straight up, straight in front, so where or take a left turn, right turn, and so on. Yeah. So basically, that's how it is done in Minecraft. I mean, there is not much to it. Like, for us it looked normal because we all been in first Mineshaft, but actually when we look at the code, we don't recognize this structure at all. Like, it makes no sense when you look at the code. and that's what I will explain, and yeah, that's the important part. So yeah, for Mineshaft it looks like that, but if you look at Stronghold, it's actually the same stuff. So if we do look at Stronghold here, go choose coordinate, so yeah, okay, let's dive down. Okay, so let's look at the portal room. Okay, so it will start roughly at the stairs here. Should start here. Yeah, as you can see, I got the I spy because yeah. Okay, so it should start here. Then it should, well, maybe make the portal room, but it will not make it sometimes, so it will just try again. Then again, there is one room. This is actually a room in the Minecraft code. Then here there is a stair, which is actually one component. This is Mineshaft that just among. This is also one room. This is also one room. So here this is also a component. This corridor. This is also one room, and so on. So each time it takes for a room, for example, for all the entrance, it took a random chance and either makes something or doesn't make anything. So as you can see, you can clearly see the structure because it carved that door but didn't make anything because there was a chance to make nothing here. And yeah, as you can see, it's also recursive because you need each time for each component to call its specific methods to make the next component. And because you don't know which component you will have next because it's random, well, it's supposed to be random, then actually you need it to be recursive in some way. And recursive, you can make it different way. You can put a stack allocator, you could put a list and chain list or something like that. But the easiest way is usually to call a function each time, and because how it works internally in a computer, it will just call that function and make a stack, which is called the function stack, and in that stack it will go each function call after each other, and by doing so it will actually well, do all in the order you call them in. So it's quite great that the computer can do, well, the programming language can do that just natively, because else you will need to program that, and that's actually a pain to program. But yeah, so yeah, each stuff here is done recursively because you need something to be done, well, you need a procedural generation, so that's easier to do it well, recursively. And yeah, as you can see, the portal room is generated is also one component. And there is also a specific check in Java, so the portal room is always done. In Bedrock is not always the case, but yeah, that's another story, I guess. Well, we'll talk about cave because it's a bit different, but cave could be seen also like that. But anyway, today is about Fortress, Stronghold, and Mineshaft. So now that we look at how it is in Minecraft, actually we need to look a bit at the code. And I know a lot of you are afraid to watch the code because, yeah, the code is, well, it's complex and so on. So that's MCP, for those that lived under a rock, I guess. It's a mod color pack. So mod color pack is actually quite simple to put in place, and is also something that we used to use because it was easier and you could just set up in IntelliJ, Eclipse and so on, and just play with it. So yeah, basically it was, well, deprecated since 1.13. There was some attempt to make it back, but yeah, it didn't survive a lot. So there is still mappings, but actually today it's more yarn, which is actually the standard in Minecraft to mod and to just look at the code. But it's a bit difficult because actually you need to do a lot more manipulation than just having straight up the code. But if you are used to it, it's actually way easier to use on the long run. Like you can do a lot more stuff in MCP, and it's more compatible with other mods, and and so on. So yeah, that's two main, and also there is the maps, which give you basically well, all you need about to discover source code, the source code of Minecraft, and get the name. Because if you decompile Java, you can get a name like that. You will get names which are obfuscated because the name were not provided with the jar, and you will get the source code with no name, and that's not interesting. So Mojang map just rename everything, so it's actually pretty great. And if you look at yeah, that part, so yeah, usually I use my tool because yeah, but you can use any tool. Like it's not really, it doesn't really matter. Like my tool is just downloading the maps and remapping everything with parent follower or SFR and special source, which is yeah, basically the same. And yeah, if you look at Mojang maps, you get everything correctly map up, and that's actually a nice way to look at snapshot, because it's instant. You give it gives you with the jar publish. Anyway, back to actually the source code. So we will look at Minecraft 1.12 because yeah, it's actually the most understood version, I think, of all the version. Maybe wrong on that point, but yeah, there is a lot of research that had gone in Minecraft 1.12. So if we look actually in the world, because yeah, we are interested in world generation, we go at generation, and then we go at structure, and it's a map gen. So there is a nether bridge for the fortress, and there is a mineshaft, and of course a stronghold. So if we look closely, what we actually see is a lot of stuff. So yeah, this method, for example, is for looking the matching mineshaft. So that's actually the seeding method in 1.12, which is still actual method, but for Fortress, for example, it was changed. So yeah, if you want to look at how it is seeded, you can look at that. And basically, what you actually need to look at is the structure mineshaft start, which will give you actually a lot of information. So it starts with one room, which is the dot room. It spawns it at the coordinate which was chosen by the RNG. Then it builds this component, it updates the bonding bows and so on. If it's a mesa, then it increases the chance to actually make more of the mineshaft, but else it will just mark the available egg. Yeah, it's not really correctly mapped, but basically it will just update the list of the start. And what is actually important is the build component. And in the build component, it will actually add each time new pieces to actually add some new pieces and call it to it. So here you can see at the room link, so there is each position, each coordinate. So as you can imagine, if there is a dot room, there is four corridor you can make. So you check for each of those, and then you add them to the list. And by adding them to the list afterwards, you will actually just call the method and go through the list of the components which were added. And for each component, you will update recursively. And if you look at something which is not obfuscated, so here is Stronghold and Fortress. Let's look at Fortress because it's same as Mineshaft and it's a bit nicer to look at. If we go at the start, so it's at the seed and each stuff to be set. Then actually what it does is it starts with the different weight setup, so it can choose which component next will be. Then it make the first component, and then it will actually update each component. So it will add a new component in the queue, and then it will update them. So maybe yeah, that's not exactly the part I want to show. In the intersecting, it's not exactly. Yeah, it's a bit messy, that part. That's the extender. Yeah, that's the one I want actually to show. So to explain exactly what I'm doing. So it chooses a start, then it adds the start in the placement queue. So that's a list, but actually you can make it a queue. And yeah, my bad. It put it in the queue. Yeah, extend bridging is part is putting me in the queue. Yeah, which is a list, but actually you can make it a real queue. And then it gets a random well, pieces to draw from the queue, and it remove it, and then it extend it. So if I want to actually put it in a nice schema, it will be like that. So at the beginning you have a queue with some element in it, so we'll put them like so. We'll take color. I don't want to do that. Can I just select that part? It's too much for them. Damn it. Let's just put a, yeah. So that's 1, that's 2, that's 3. There's 3 elements in the first queue. Then we take 1 element, so it will be number 2. So the queue will look like so. Let me take my pencil again. So there will be only 2 and 1, and 3 was taken out, but 3 is extended. So actually 3 will produce, for example, 4, 5, and 6 here. Well, that's not very... 4, 6, and 5. And those will be added to the queue. So the queue will look like that. 2, 1, 4, 6, and 5. And it repeats. So each time it takes 1 element and it adds an element. So if you look at that and you are, well, you did some computer science, you will say, yeah, that will not terminate. And I agree with you, because, well, it will keep on going and the queue will keep growing till actually it reaches its capacity. Then it will either throw an error or just, well, crash. And what is actually interesting is that there is condition in the Minecraft source code, and those conditions are actually that we can go more than a certain number of blocks. So that's the 112 here. So when you are extending, so when you are adding a new number in the queue, you are actually checking first that you are not that far from the starting position. If you are too far from the starting position, actually you can't extend more, because well, if you are extending more, you are increasing the queue and so on. So that's also to make the Mineshaft and Stronghold and Fortress a bit compact. So you check that, and because you are checking that, here you are, if you are adding 4, 6, and 5, actually 5 is not possible because it's too far. You are only added 4, 6, and if you draw enough of it, at some point you will only add, well, 0 element, because you will not have anything that is actually close enough to the start, and you will have the list which is decreasing, and you will, so you can say that next of the length of the queue will be actually less than the actual length of the queue, which is important, because if that decrease, then actually it's it can finish, and that's important when you are doing recursive stuff, but you check that the function can actually terminate in all the cases. And that's an interesting condition in the Mineshaft and so on. So yeah, basically if you listen from the start, I already explained how well, the 3 type of generation works, because it's just that behind the scene. It's just a list and adding some element. So you choose an element, then you are extending it in different direction. So if you are of a room, you take one of the 4 corridor, and each time you choose if you want to go and do a corridor, or if you don't want. So if you don't want a door, then you don't do it. and for each you are adding more elements to the list. And if you are in corridor, you check if you want to do a left, a right, or go straight, each time with a weight. So maybe you don't want to do it, so you not do it. And then you are adding more elements to the queue till some point you are far enough, so you are crossing the border and you are far from the starting point, and then the queue will decrease because you will not add any more elements. And that's why we have this shape of, well, this path and so on. And various paths which are impossible because at some point we decided that we don't want to do them, and because also there is an interesting fact that you can't go in a path a second time, because if you go in a path, well, it checks that the path already exists. If the path already exists, it doesn't take it. Then you can't go recursively through all the map, because there is also one other condition. If you want to not do something infinite, which is to not go in something you already explore. Because if you take, for example, a graph, because basically it can be seen as graph theory. If you have a cycle, which is basically all the points linked together, if you go in cycle, then you are running at the infinite. But if you say that at some point, if you reach a node that already has been visited, you will not go in the next node, then you are actually breaking the cycle. So in the Mineshaft, it's the same stuff. We don't actually go in a path which was already explored. In some way, there is actually edge cases, but most of the time it's that. And that's actually for each. So Fortress, well, it can hold in one class. So yeah. Stronghold, there is this is cap repository. So yeah, if we run it, for example, at the beginning we are actually making the start. Then we are making the 5-way crossing. We are taking a right turn, a corridor. Then we are making a square room. On the square room, actually, we are doing a left turn right away. We are making the corridor, a 5-way crossing again, a left turn, corridor, 5-way crossing, and so on. So actually, you can see a lot of stuff. And then there is a portal room which happen here, which is because we are actually reaching the condition to make the portal room. And yeah, you can actually see the recursion, well, not the recursion, but the output of actually making the map. And that's actually how the old game were made. Like if you played a rogue game or some stuff where you were blind in it, and you basically just add some path at the beginning, and so, well, it's old game, but maybe some people know about it, and you choose to go in some way, then yeah, it's a maze behind, and you can encounter some monster and so on. It's basically the same algorithm behind, well, mostly same stuff. And yeah, and if we look actually at how it is done as in the stack, so if we go here, we run Fortress, for example. So here again, there is a depth queue, which is interesting. So at the start we have one element in the queue, but if we go, we have 3 elements. Then at this point we started adding no more element, so we draw more element than we are adding. So we go back to 2. Then we are again increasing. We are diminishing, increasing, diminishing, increasing, diminishing, increasing, diminishing for a while. Then we are increasing, till some point we are actually done with the whole map, and then we are just clearing the leftover. So then we are just diminishing. So yeah, if we look actually, that will be in that part in the loop here. So let's take here and let's run that in the debugger, for example. So actually there is 3 in the queue, 3, 4, 3, 3, 5, 6, 8, and so on. We are increasing. Then at some point we'll go through the max, which is 20, as we saw earlier. Oh, we already passed it. We are 11. Guessing we are not staying. 10. Yeah, at some point, yeah, you are adding one element, drawing one element, so it doesn't update a lot. The size stays the same. But which is nice because actually it doesn't go that far. Like it goes 20 and then it goes down rapidly because the room are quite large compared to the condition, which is well 100 blocks. So if you divide that by 10, so you get 10 at least, and if you count the intermediary path, yeah, you get at most 20. Well, yeah, and then you go down till you actually have none. So if you put it as a graph, the queue length will be something like that. At the beginning it goes rapidly to some point, then it fluctuates a lot. Maybe at some point it goes again up, but then it goes down, and at the end it just goes straight down till there is none. So that's the queue length, and that's actually recursivity, because as you think about it, it's like you are calling something, then you are calling another path, but actually you are also calling a second path, but this path will call some other stuff in it, and so on. So because our recursivity is done, you will go first and explore the deepest path, then you will go back till the branching, and you will explore the second path, and that's just a stack. So actually it's recursivity. It's just done with a stack and an accumulator, which is the best way to do it recursively. But actually, yeah, it's just recursion behind the scene. And it's a nice way to see it like so. Okay, so it was actually quite fast, but I'm thinking it might not be clear for a lot of you, and well, I don't know if you actually have background in it, so yeah. I think yeah, Mineshaft, I don't have a library because right now I don't have it on me, but I can put it one together. Yeah, this was yeah a quick one because yeah we needed to cover that part because it's always interesting because some people ask for the largest of something or just with the most of some room or something. We can actually make like a spaghetti mineshaft or so on. Like we can actually make so that we have the center dirt room, for example, and then we have only corridor because it's actually checking for each component that we are actually drawing the correct stuff. So if we look at for example at the fortress, for each extender we have actually some conditions. So if we are looking at create rotated, for example, no, not that one here, extend forward, the case which are extend, yeah, so in extend here there is a number of try to do the extend, and we are actually making just a next int, and depending of the next int we are actually making the well, adding a new pieces or not making a pieces. And there is the check intersect any, which I told you about, which make it so you can't go back in a previous path, because if you go back in previous path and there is actually a conflict and you are doing something infinite because you are making a connected graph. Okay, so that was covered, but I forgot something yesterday and I want to go back at it. So yeah, Mineshaft, to recap, it's basically recursion behind the scene. Fortress and Stronghold is also the same, and it's drawing one element, choosing which way you want to extend it, and for each extender you are getting some possibility, you are adding them to the recursion queue, and you are going through iteratively the queue, and for each of them you are drawing till you are reaching the condition, and then you are going through all the elements of the queue. So you are doing them in different steps, and so you are actually well doing them all, but in a certain order, which is making all the path. So you are taking the first path, going till the end, or so. Then you are actually going back to the first branching, doing the first branching, and so on till you go back to the starting point where you take actually the over branching, and then you have your full path. No, what I want actually to go back is yesterday I talked about noise and I talked about the lacularity and the persistence. And I think I overlooked, well, I didn't overlook, I mean, I went too fast on that actually didn't explain some stuff on it. And maybe I want to show you what actually those coefficient does. So here I have some stuff. So basically I compile mind map with a different type of lacularity coefficient and persistence coefficient. So for example, the normal mind map. So let's just run it. Let's take a new word, so seed1, so we are clear, it's all seed1. Then we go to the nether, and as you can see, it's quite nice, it's the actual nether we are used to in 1.16. Yeah, 16, and which is the 5 biomes which are made with the parallel noise. And as you can see, it's a coherent noise because there is a succession in the biomes. So keep in mind this, and now let's just run by adding a lacularity of 3. So we are actually increasing the frequency of the octave, so we are increasing their size, and persistence of 1 over 3, so 1/3, and we are so decreasing the amplitude of the smallest octave. So the big octave will have a larger importance in it. So if we run that, so again I'm putting seed1, so there is no change in it, it's the same seed. And if we look, then actually we see nothing because we need to zoom out a bit to actually see some stuff. And as you can see, actually the size of the biome are quite large because of course we are increasing the frequency a lot. Yeah, because increasing well, moving by 2 to 3 actually does a lot because, well, yeah, we are. It's not linear. It's quadratic, and we are also reducing the place of the small noise. So actually, if we look a bit close to the noise, so it will not look like that in the nether because the biome are smoothed down, but there's less details to actually the biome if you wanted to look at it really. So let's try more persistence. So again, more persistence is decreasing the amplitude of the octave as you go in the larger octaves. Not larger, but smaller because actually they matter less. But so yeah, the overall octave. So seed1 again. Yep. And as you can see, is it actually persistence or is it lacularity? Which one? I think I messed up. Let me check the last one. Maybe I messed up, I think. Sorry. I mislabeled them because that doesn't look. Yeah, actually, that's the one. Okay. No, it's okay. So yeah, that's less persistence because we have actually bigger noise which are important in it. And yeah, so we have actually less proportion of over noise in it, so we actually have less biome which are represented because bigger noise have more importance in it. So we actually have well, if it was one value here, it will extend more because it will not be changed by over noise octaves. So yeah, this is actually normal, and this is actually more lacularity. And by adding more lacularity, so frequency, we're actually distancing the different noise. And of course, never waste are the background which is by default. And because we are distancing the noise, we are actually seeing that a lot of default value are put in because we are not in the range for most of the new biome. So yeah, that's actually locality and persistence. And yeah, I'm sorry, I should have started with that. Actually, it would have made people well, more concentrated on that. But I mean, I didn't thought about it before, so it was just something I had prepped, and yeah. So yeah, so it's really important to choose coefficient carefully because yeah, with 2 we are actually good, but with 3 we are at the same zoom here and here. Actually, yeah, it's not the same well stuff, and that's why actually in some snapshot there was some biome which were finicky. So yeah, it's better to have something well better. And as you can see here, we can clearly see the difference. Here we are seeing, yeah, it's bigger, but here we clearly see the distanciation made by the locality. So as you can see, yes, biome are quite spread out compared to here, which are quite well together. So yeah, that was some stuff I missed yesterday, and I should have put it there, but because it was already 1 hour, I think it was better to cut it short yesterday, but yeah, you know, we had some time. So yeah, I think I covered everything I wanted today. It was a short one, but I mean, the main part was understanding that behind some stuff in Minecraft there was the recursion, and how actually Mineshaft, Fortress, and Stronghold are done, which is by extending each component. So each component is a function, and you are calling new function from it, and you have a stack, and you are going through the stack. So yeah, of course, for Seedfinding, how it can be useful is finding the Stronghold start, which actually is simple because it depends only on some biome requirement, which is basically all the biome, and then it well, it's actually a bit complex because Stronghold, for example, are pre-generated in rings, and on each ring you have basically all the stronghold, well, a number of stronghold on it, and what you want actually is have the spawn, which is usually at 0, to move close enough to the ring, which is at 1.5k, first ring, and you want it to be moved enough to be close to the first stronghold. What actually you can do is have a stronghold which is just a spaghetti, well, a line, and so it can extend enough to be close to the spawn. So when you are speedrunning, you actually can just dig down and enter in the stronghold and just, well, run towards the portal room, which is actually one of the goals. And we actually have a spaghetti stronghold. I think I don't have the seed, but I will put it in the description when I have it right now. But it's quite fun because, yeah, you can see the stronghold, and yeah, it extends a lot. So yeah, I think I covered everything I wanted. Of course, if you have questions, just ask them because I will answer them. Not, I mean, I'm talking and talking, and yeah, I know it's recorded and people will maybe understand a few things afterwards when we will listen about it. But if you have a specific question, maybe ask them because, yeah, I will answer them and maybe you will understand some stuff better. So yeah, if you have no question, I'm guessing, well, yeah, I will terminate that, and next week we will talk about another topic, and next week topic will be, yeah, a lot more complex because it will be about Laticity. And you might actually know it because it was featured by, well, Matthew Bolan, of course. If you don't know Matthew Bolan, then you are missing something, actually. But so Matthew Bolan here, and yeah, he made a nice series. Well, he hasn't finished it yet, but basically, yeah, it explains the linear algebra behind the Minecraft Seedfinding. Well, Minecraft in general, but in particular for Seedfinding, there is a lot of algebra which can be done to actually improve a lot the speed. So yeah, Laticity, it will be so Monday, same hour, of course. And yeah, we'll talk about electricity and how we can be used actually in a Seedfinding project. Would dislike it? No, don't. Just about it. Yeah. Anyway, thanks all for tuning in. I know it wasn't that great of a stream today. It was quite short and it was on a really specific subject, but I mean, I wanted to clear that out so we can refer it to it back later. And yeah. Anyway, thanks for tuning in and see you Monday, I guess. See ya.